And then there's calculation questions, which we will go over today. Okay. So I'll do examples, or I'll do an example that is pretty close to what you might get in the test. It won't be the same numbers. Okay. So you need to know the theory behind it all. The test is 50 minutes. It's exactly the same in that respect as the civil test. You have a little clock going tick, 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 and you've got the numbers. Yeah, it's the same rules as well. You get a piece of paper and all the rest. There was a student in the degree asking me, you know, how can I get more marks if I get close to 50, like 48 or 48 and a half? Can you go back and have another look at my assignment 1 or 2 or whatever? The problem with that is that I've already given you all your marks for your assignment, and at the end of the year there could be one student that's half a mark off getting an A, another one half a mark off getting a B. He finds out the student who was half a mark off passing got an extra mark in assignment 1 or 2 just because we liked him or something. He's gonna or she's gonna want that mark too, and it just goes on and on and on. So the only flexibility I've got is the piece of paper you hand to me after the test. I might find something you've done the calc wrong, got the right answer, and put the wrong one into the computer. So I can go back over my tests and revise that one, if I have a reason to. And of course, assignment 4. So if you put in a really bad assignment 4, then there's no chance of any flexibility for me. I normally mark assignment 4, you probably don't believe this, but fairly generously, so that we have a good idea of where the student's sitting in terms of everything. And, you know, it's hard to give extra marks on assignment 4 if you haven't put the effort in. For example, I think I'll just do the 2 elevations, that'll do. I won't bother about the reinforcing down the bottom, just do the structure. I'll just copy what Roger's done, so just do an outline for one of them. So obviously the outline's going to get no marks. You're going to lose marks for not doing the reinforcing. You end up with 2 marks. Student thinks he's going to get 8, he gets 2. Student decides that 8's enough to pass the course. I've got nowhere to go, right? I can't help in any way. Students made a really good effort on both elevations. They've even tried the 3D. They've got a reasonable on the 3D. They've tried to put a few things in from the internet, half successfully, and they've tried a little bit of the details, albeit not that good. But there's flexibility there for me to say, well, you know, maybe with that effort, there's a chance of pumping the mark up by half a mark or so, or maybe 1 to get them over the line there. So it's kind of, that's the way it works. It works a bit like that with exams. We, believe it or not, go into a meeting in late November with all the results in the grade book as they stand, and then we might find, I don't know, not randomly talking about anyone, but say the student at the front is on 48.5, right? Say 48. 48's about the cutoff. So we all talk about him, and I say, well, he's been filming and uploading stuff for me. I say, that doesn't matter, that's not good enough to pass. But then they might say, well, actually he's got an A, a B, another A in the other classes. It looks like this one, he was so close, right? And then they'll say to me, go back and see if we can get him over the line, because we want him to carry on, you know, each semester, right? Then we have another student who's on 48.5. They've been found cheating. Their other subjects are all D's, all right? And the class attendance has been poor, because we can see that straight away now, okay? And it's like, well, why should we make the effort to go back and look through everything they've done and see if we can, in the exam I'm talking about, get them more marks. So, yeah, there's that, so those discussions, but they go on behind closed doors, right? The initial idea is to try and get people that are close up, but it wouldn't be the first time I've been asked to go and take see if I can lose some marks so the person doesn't try and appeal it, okay? Sometimes when we're marking, we're a lot more generous than we have to be. And some of you would have noticed that with the last assignment, getting all the bars wrong but still getting 7 out of 15 or something like that, okay? So it depends on how we mark things. Yeah, with respect to the CAD side of things, I've also had students that are on the borderline that don't look like they're going to pass, emailing me. So it's dodgy as to whether they're going to get there or not. Do I drop the subject and do it again next year or not? I can't really answer that. That's kind of like I can't answer that purely because that's me telling you you should stay on and then you fail, or vice versa. So what I can say is I've had a lot of students over the years that have failed the subject, come back the second year, stood right there on the first day of the next semester, and they've got a B, and sometimes close to an A. And those students have ended up in work, in drawing, because they've understood everything very, very well, right? And you compare them with another student who's slid through on a C minus, that stays on the record, whereas the person that's failed then got a B or an A, that's all the employer's looking at. Yes, they could see a transcript. Yes, they could say, hey, what's going on here? But on your CV, you don't put that. On your CV, you put B or A.
So the failed subject will go to the transcript as well?
It will, but they don't all ask for the transcript. On your CV, when you're applying for a job, you only put your better marks, and if you've got good marks, even if you've repeated them in subjects that they are interested in, they're not going to go back and say they failed it the first time, they got an A the second time, or they failed it, we're not employing that person. It just means you've ended up with the ability, the A ability, whereas the person with a C minus first time round, that's the ability they reached, you know. So it's not a dumb idea to repeat and get a better mark, but you can't repeat if you've got a C minus. That's it. Yeah. So it's the same with all subjects. If you're thinking of becoming a geotechnical engineer and you get a C minus first time round, well, you can probably, because there's so many students applying for work from Unitech when they graduate. We have roughly 80 to 100 students a year graduate, so you're up against them, and they all pile on the same jobs. Yeah. Oh, don't worry, the A students get eaten up pretty quickly. They get taken before the jobs even hit the paper, so you're really competing with the big ones as such. Yeah. I get a lot of opportunities through different people I know, from companies that email me, the HR officers email me, so what I do is I ask them, do you want to narrow it down to a small group that you can choose from, or do you want to open it up to everybody at Unitech? If they say they want to open it up, I put it straight onto Facebook, and I pass it on to the secretary or the PA, not my one, the boss's one, to put it onto Moodle to all you guys, okay? If they say no, I want to reduce it, I said, well, you have to write the blue, I can't do it. And you have to put what grades you're looking for and what subjects you're looking for. Then I put it on Moodle, and then it goes to, then I put it on Facebook, then it goes to Moodle. So it's a good idea to be on the Facebook site. The other reason for being on there is you might get a job, you're not very happy at it, and you'll still be able to see the jobs that are coming through, and at that point you're probably going to do better than a graduate to get into your second job, because you've got some experience, right? So it's not a silly idea to be on there as well. And of course, if you get A grades in most subjects, then Ingrid will be interested in looking at you as a past student as well. Okay. We have had students help with the CAD who've been very, very good on the CAD and the civil drawing, but not so good on some other subjects. We have had that in the past, but generally she tries to pick ones that can do one or two subjects. You probably noticed that. Yeah. They don't have to be degrees. They don't have to be any nationality. You'll probably notice we pick different nationalities. I get a little bit of a say in it, but I don't get a say in like structures or geology or something like that. So, yeah. I guess that's about it. Good thing about this subject, you don't have to see me again if you pass it. And the second thing about the subject, you've got, that's all, yeah, that's the sign. And the second thing is you still don't see me again. No. The second thing is that you've got study week up your sleeve the following week, and you don't have to worry about any exams. Okay, so your big test is next week. And it's only a 50-minute test, so it's not like a huge 3-hour exam. For those that are wondering about, you know, I don't know what you put on your comments, whether you've done the survey or not. If one of your comments was it's too hard, there's too much work or whatever in the subject, this year is the time for revising, so all of what you guys have done, plus some example students' work goes to Wellington from me, and the whole lot of the different polytechs are reviewed by 3 people. And so if I'm not up to their scratch with my notes and the assignments and the students' work, they write a report back. It comes back to my boss and me. So it is being monitored this year, first time for 4 years. So we'll just see what comes of that. 4 years ago it passed no problem, but I don't know. Who knows what's happening. I do know we teach a slightly higher level than most of the rest of the country. So it is thought upon as being the sort of premium place to study for this subject, he says. Okay, we're getting some good numbers in here now, so the reason for coming today is not to listen to me waffle, it's to listen to me give you some examples of what is actually in the test. So I'm about to turn on editing, and you thought you would just sit here listening to me? Wrong. You are going to be doing some work as well. Or sitting there with your arms crossed, whatever is your thing. I'm going to make available the revision questions. After the class, I'll make available the answers. So, let's see if we can put some power on. Done that part. So for those with laptops, you'll be able to see this, the questions. I will bring it up on the big screen as well. Okay, so I have a bit of an issue. I don't want to show you the answers without going over them, but unfortunately I am not an Albert Einstein, so I do need revision with answers. Okay. Okay, I can do it. So there'll be a little bit of turning off the monitor every now and then, so that I don't show you the answers, and just to check that I've got the right answer before I put it on the board, otherwise I look like a bit of an idiot. Okay, so there will be, just so you know, there'll be a plate question, three plate question today, covering most aspects of the plates. There'll be a structural girder, and there will be the reinforcing question, which will be an abutment. I'll explain the abutment to you, what it is, where it comes into engineering, and how most of you will end up having to do one at some stage in your life. And that is the end of today's mathematical questions. And the cross section through the under the building notes, which was week I think it's week 10. So under the building notes here, there was a cross-section of the building and a cross-section or a sort of a 3D isometric view of the bones of the likes of a warehouse or a factory. So this one here is in the test, and what you need to do is remember those and learn for those. Good thing is you've got one more week. The test is not this week, it's next week, so you've got a bit of a week to digest this. There will be at least one, maybe two questions from there, so that will be a good one to learn. And there will be one or two questions from this one as well.
So you have to remember all these names.
What's that?
Just then we need to know all these names.
Well, put it this way, if in a year's time your first job is to walk onto a building site and somebody says to you that take your dimensions from the continuous footing, and you stand there looking at some guy's feet, he'll say, didn't they teach you anything at uni? No, I didn't learn that. And he's probably one of my ex-students, and he can probably find that for him and say, yes, they did teach you this, okay? So although it is architectural in some ways, it is still something you're going to come across all the time. For example, your first job might be extending a building. So they rip off all the outer linings and they add to the building, and you're doing an engineering structure that might be an extra room or something like that. And then they'll start talking about dwangs, top plates, bottom plates, studs, floor joists, etc. Okay? So it's not like you can get away from these things and run for miles and work away. So that's why also some of these terms are New Zealand terms. I don't think you'll find the word dwang anywhere else in the world. So yeah, this is a New Zealand certificate, so I guess you have to suck that up. DPC stands for damp proof course. It's what's put between concrete and the bottom plate or whatever is being put on the concrete. So you know how you see a building site and there's a concrete slab there and they're about to put the frames up. They normally put the DPC underneath the frames as well. It stops any moisture rising into the timber, and we've talked about timber. You've done timber in materials as well, most of you, and timber is very much affected by the moisture content. So those two are the only two that are going to reflect quite a bit on the test. So you really do need to go around them and make sure you're looking at what the arrow's pointing at. There's a couple of times that the answer is the same. you'll notice that ceiling joists are pointing at two different ones. Okay, so I've covered that, I've told you about that. It's up to you whether you take that any further. I'm not going to look at the answers in front of you. What I am going to do is look at the question. So here's the question.
Jojo, can you bend the microphone a bit lower? Is this blocking the screen? Yeah. Yep.
Is that better?
That's
Yeah.
perfect.
Okay. All right. Okay. Okay. So with the plate design, you need to remember me talking about Grandma's quilt and Grandma sewing around the outside edge, and I said that with reinforcing. Unfortunately, a lot of you didn't take that into account when you were doing the reinforcing. You always put the bars as hard as you can against the edge. So in this case, unlike reinforcing where you had the cover, in this case, you have a minimum distance you can keep from the edge, and that is calculated first. And you also have to bear in mind that AA and CC have a maximum distance as well. So you can't breach either. I did cover the reasons for that, and that is one of my model choice questions as well. Well, whether you get it or not is another thing. I had a count up, and there's over 90 multiple choice questions, so you know you're only going to be doing 9 of them. But one of them was what do these things cause, and bursts, etc., and tears in the metal. One of the things that happens if you go too close to the edge, or you have too much distance between your holes. So, the first two things we have to calculate is our minimum distance and our maximum distance. If you get this first one in the test, then you can go yes, because it's very easy. It gets more complicated, but not that bad. Okay. I will save this whole board here for the excitement of reinforcement calculations, and we'll do this for our plate design. So the first plate is 400 by 500. I'll just call this number 1. So the minimum for number 1 is 2.5 times the bolt diameter. So what is the bolt diameter here?
Maybe very cut 16 millimeter hole or 16 millimeter bolt.
Okay, well the circle is pointing at the bolt hole.
Ah.
That's why both of those two letters are capitalised. So that is a 16 millimeter bolt hole. It's really important that you understand that. So if the bolt hole is 16 millimeters, what is the bolt diameter on the metal?
14.
So please don't do it the other way around where you go, oh, it's a 16 millimeter bolt in a hole, because you will get these calculations completely wrong. Myrtle doesn't allow for a slight mistake. Incidentally, can anyone tell me what's wrong with my leader there? It's not starting in the right place, is it? It's really poor. Shocking, isn't it? Okay, I'll take half a mark off myself for doing that. Okay. Yeah, it should be the bottom center of the word hole. Good. Sounds like you guys have been learning something, which is a bonus, as opposed to nothing. Right, so we have established that it is 14 times 2.5, which equals 35. Is that right?
Yes.
I have the answer there, I'm just In my book, that's 14 times 28 plus 7 is 35. All right? So that's your minimum. And the maximum is going to be equal to 32t. Incidentally, that's an interesting number, that 32. It's also how you calculate the lap if it's not given. If there is no lap given, and you'll find in the test there is no lap given in some cases, so you'll have to assume 32 times the diameter of the bar is the lap. All right? But that's something different, that's reinforcing. 32 is also the number you need for the plate. And so 32t is 32 times the thickness. And so 32 times, what's the thickness of this, is 8, equals 256. Now there is a little add-on to 32t, in brackets, no more than 300. So if, for example, that had been 10mm plate, that would have been 320, so the number would come back to 300. So there's a proviso there of no more than 300. So 256 is our max.
So if you reduce the number to 300, the rest you have to...
If it's over 300, you go back to 300. Yeah. So 320, 330, 340, 300. Okay? Okay, so we've got 400, we've got 500. So let's put our minimum, we always put our minimum in first. So 35, and that's to the centre of the hole. And then we divide what's left by 2. So if we get our calculator out and divide that by 2, that'll be 500 minus 70 is 430, right? So that'll be 215. Let's have a look at 215. That is fine. When you look at the 256, it doesn't breach the maximum. So I'll get my red pen out and give that a big tick. So had you been asked for A, the answer would have been 215. If you were asked for B, the answer would have been 35. Let's do it down the side. Down the side, we have 35 again, 35 here. So 400 minus 35 minus 35 equals 330. 330 divided by 2 equals 165. I think it was pretty obvious anyway that that was never going to breach the maximum or the minimum, and that's the distance. And that's the answer. And that is ideally what you are trying to do with your own plate in your assignment, and that you should have done before you even came up with a number. All right? Unfortunately, you cannot change it now. So therefore, you cannot get your detail right. You would have got half a mark for getting it right in assignment 3, by the way, if you did the calculation right. In the assignment, you've got the added problem of a column welded onto here. So if you can't do that, then you need to bring it in. I think you could be lucky enough on the assignment, just to help you out a bit, you might find that your 2 bolts may fit here without breaching the minimum and maximum. Or if you've made this bit long enough, let's hope you have, you might be able to do it here and here.
So why don't you just change the drawing to suit the reality?
Because I've already given you half a mark for something that was wrong.
Have you though? Because
Yes.
what we do is take marks off rather than give marks.
No, I'll go back to assignment 3, right? You did, well, I'm assuming you did the plate. right? And you come up with a number, and I said to everybody before assignment 3, whatever the plate is, I'll just make sure you've done the calc right, and I'll give you a mark as a tick. If you don't want to do this before you do it, that's fine, but you cannot change it afterwards. And I distinctively said that if we go back through all the videos.
But that's sort of not really, as you're developing drawings, things change, so it's not.
Yeah, in the real world you would change it, yeah, but you get in big trouble for not doing that calculation first. So if you still had a job, you'd be asked to change it, yeah. But you'd also be asked to explain why you didn't do that before assignment 3. Yeah, we done? We can carry this on afterwards if you want.
Yeah, sure.
Excuse me.
Right, yes,
Is there maximum for the covers?
maximum, so maximum this way, from here to here.
Yeah.
Yeah, it's the same as this maximum here. So in the assignment, you've got a 10mm plate, and you've got a, I think off the top of my head, a 20mm diameter bolt, right? So in the assignment, it'll be a different minimum and maximum. So you can have your 2 bolts here, I think. By the way, you can put your bolts within 10 mils of this weld, okay? Of the actual column itself. So I will allow it to be within 10 mils to 6 mil fillet weld. So you need to be 10 mils from the edge will be enough. Alright, in my opinion. I think you'll get a what you call it on top of that.
But that's not really true either, is it? Because you can't actually get a drill close enough to the column to actually drill that hole, unless you pre-drill the hole and then you...
Well, this gets welded to here, so the holes will be already pre-drilled on the plate, probably. I don't know.
And you could turn it on your side and drill from behind.
Yes, you could. All right, so we'll move on from that. The detail of the plate will require you to put those numbers on there. And obviously, if those numbers work, then that'll help you with getting your 1 mark for the plate detail. But I have offered an extra bonus mark for a couple more details. I'm also offering a bonus mark for going further with the 3D as well. So the next one introduces a slightly different formula. The next one is, we'll call that question 1. And we'll call that question 2. So while we're on the subject of taking marks off, there is other ways to do things, which I've experimented with over the years. The problem is I'm trying to get students from technical literacy drawing to getting close to a professional drawing in this subject. We used to have different levels. This would have been level 3. If students keep staying at the technical literacy level, then probably they would receive a lot less marks for some of their hand-ins than the half a mark or 1 mark off. You might think I'm fussy for things like that leader, which is again wrong up the top. But there are other things that industry doesn't tolerate. For example, getting your dimension settings wrong, and getting your text heights wrong, and putting leaders through dimensions and stuff like that is just like, that's kind of a little bit of a warning, and then you don't work in industry anymore, okay? It's kind of a little bit like an artist versus a kindergarten drawing with a paintbrush given to grandma. There's a big difference, even though they look the same, and you hang them on the wall in a frame. There's a difference, right? It's probably not a good comparison. My brain doesn't work like that.
Brother,
Yeah.
as well as well,
there's 4 rows, 1, 2, is this the right question? Is that question 3?
That's question two.
Oh, yeah, okay, sorry. Thank you, you're really good at pointing out when I'm wrong. I appreciate that. You have some skills that no other students have. 1, 2, 3. Right. Okay, so in this particular case, we've got a thickness plate of 10. So our minimum is equal to 14 times 2.5, which equals 35 again. The maximum this time is equal to 32t, which equals 320. However, that now is dropped to 300. The good thing is that is actually one of the multiple choice questions in the test. I go back and interrogate that 32t and ask you what the maximum distance would be. So if you get that one, it's like an easy multi-choice question in my mind. And yes, even although I got this wrong when I drew it, make sure that you don't get it wrong in the test. If there's 3 rows divided by 3, it's quite a common mistake. So immediately I'm putting 35 in here, and I'll find that the answer is not going to breach the maximum 550. In this particular case, 550 minus 70 equals 480, divided by 2 is 240. And in this case, it is 710. 710 minus 70 equals 640, divided by 3 is 216, right? 13.3, yeah. So that's the answers for all of those. When we look at the 213, we're always comparing these numbers here with the maximum. Most students do this reasonably well. What I'll do is I'll wait till test day to remind you about decimal places. Really important that you get the right decimal place with your answer. Right? Lastly, and this one is one that will pop up. Oh, by the way, the numbers are different in the test, but this is one that will pop up. And it's one where you have to change things around a bit. So, going back here, so question 3. This time, and I'll try and draw it properly. Let's see if I can. Easy. 1, 2, 3, 4. 1, 2, 3, 4. And how many across there? 1, 2. Once again, the minimum equals 35. The maximum is the same as the previous one. It's 10 mil thick. The maximum equals 300. We put in our 35. 35 on the other side. 35 here. 35 here. And 780 minus 70 makes 610. Is that correct? 70. So that makes 355. And we have a problem, so I'm going to put that in red. Any suggestions what we're going to do now? Reduce. Exactly right. So we reduce it down to our 300. And what do we end up with at the sides? Take that. And we end up with 90 on each side, do we? Okay. Coming down the other way, we have 710, which is the same as last time, I think, so that's 213.
90 each side or 45 each side?
Is it 90 left over, so it goes to 45? No, it's 90 left over, 90 on each side.
Yeah.
That is right. 213.3. So those ones are okay. So, my tips for this one. The first thing that you want to do is make sure you're calculating the right number. The amount of students that get asked for A and they go and calculate C, or the other way around. So make sure you're calculating the right letter. Double check that. That's probably something you could do at the end when you're going through checking all your answers. The second thing is, remember the 300 rule. 300, no more than 300. So you'll find that I'll have plates that are 12 millimetres thick, 10 millimetres thick, 8 millimetres thick. You've just got to do the maths, no more than 300. And then lastly, if the maximum is breached, then you bring it in and you work out what the new minimum is going to be, which is kind of what you might end up doing with this on your project. Okay? So if it's impossible to put the bolt holes in the corner, then bring it in to where the first position is here, and then where the first position is that you can fit them in this side. Some students have only done 350 by 350, so they're going to struggle. They may be able to put the bolts in there, I'm not sure. Okay, so that's plate design.
Is there a minimum distance between the bolts? I think there's a maximum, but is there?
Yeah. Between the bolts or from the bolt to the edge, the minimum is 2.5 times the bolt diameter. Okay? My girder. So what I've done is I've used the same girder, same sketch, sorry, but I've played with the overall length, the weight of the angle, the other things I've played with is the size of this beam here, the size of this channel, and also the size of the plate, and also the size of the angles. So whilst I'm going over this in revision class, this will not necessarily be the numbers you'll be crunching in the test. But if you understand the concept, it'll be very, very simple to put different numbers in there. Okay? And the test will look something like that as well, whereby I give you some numbers and others will be letters. And yes, some people will be unfortunate enough to get N, whereas others might get B, which the answer is 1. Okay? What I've done with most of these things is what Moodle can do is I can say, I can nominate the questions that are easy, in my mind, and I can say give every student one of these, or 2 of these, and these are the hard ones, give every student 1 or 2 of these, okay? The problem with doing it like that is that, in my mind, that's pretty fair, because you get an easy one, or a couple of easy ones and a couple of hard ones. But the problem with that is it does repeat them sometimes, as you may have noticed with the civil drawing. Alright, so it just tells Moodle to pick 2 out of that bunch, but it can pick 2 of the same. So if you get 2 questions the same, you know, at the end of the day, if you can't answer it the first time, you won't the second, but also it can work the other way. If you know the answer, you've nailed 2 in the bag, okay? Once again, the thing to watch here is that the answers are in metres, not millimetres. Whereas if you go back to the plate, the answers are in millimetres, right? So this time around, because we're calculating kilograms, the amount of students that did not put a total weight on their steel was frustrating, and also the reinforcing. The whole reason for doing any quantities is to work out the total. So you can go to your boss and say, hey, we've got X amount of steel, X amount of kilograms, and the boss will put that on its calculator and go, okay, what's the current price for steel from Fletcher's? Oh my God, it's going to cost us this much, okay? Not, here's my quantities, you can spend the next half an hour totaling them up. Also, in the real world, you swap things with your person beside you. So they will look at your drawings, and believe me, when you're in the real world, they will be much worse than I am in putting red marks all over your drawings that come back. You'll also swap your quantities, and they'll be checking through all the quantities as well, and they'll come back as well. And you'll be doing the person beside you as well. So it's kind of the way it works. Your workmates, and then suddenly they don't like you because they've had to spend a long time checking stuff that you did wrong. So, yeah, that's the way how it works. So let's have a look at this chart up there, and I'm going to draw it, and we'll come up with some answers. I will need my friend at the front here, who will not get any extra marks for doing it, to do some calculations for me. Another good thing about doing all this filming for me as well. It'd be really good if you could come back next year. Now, if you don't like revising this particular question, you can go back to the one that I did in week 9. Go back to the video, have a look through it. It's probably, I'll go through it a lot. I went through it a lot slower. Okay. Some of this is extremely easy, and some of it does require a little bit of a memory. So the first thing that I better start writing all these things up here. We'll get all confused. So remember, number off, length, and width, and mass per metre, and mass per cubic metre, or is it square metre cubic? I think it's cubic, isn't it? Yeah, cubic. Total. And over to the side here is thickness. Okay, so 300 TFC 46. There's one of them, it runs the whole length. The whole length in this case is 12 metres. So A is pretty easy. You only have to look up the top to see the length. There's no width. G, mass per metre. Well, the mass per metre is found very easily by number 46. Unfortunately, some of you got on the internet for your assignment, looked up the member that was on the internet, found the mass per metre, thought, yay, gold, and put it in there instead of this number here which you were asked for, which made that number quite different. And you'll be wondering why you possibly lost marks for that. I wanted you to do it as per the steel schedule. So 46 is the magic number that we need there. Nothing there. And so we need someone at the front. We need someone at the front, not looking at anyone in particular, to go, don't look like that. Turn the camera around and show your happy face. 12 times 46.
552.
Oh,
Oh, that's
what
fast.
was it?
552.
552. Don't you hate it when there's always someone at the back that steals your thunder? Never mind. Next one is equally easy, okay? 533. Universal beam. 122. 122 goes there. One of them. Length 12. The answer is. Oh, he's gone quiet.
1464.
1464. Good to see a right-hander answered that. Okay. 89 by 89 by 89. Actually, the true call up for this is 89 by 11 UDA. That's slightly wrong there, but doesn't matter. Okay, so the angles, there is 2 here and 2 at the other end, so that makes 4. And the length of the angle we have to calculate. So it fits here, between there and there. The beam is 533, we already know that. We know that because that's the number there. What we don't know is this little distance here. Hold on, I'll just put my jacket on, I'm getting the full blast of that through the corner here. You okay? Yeah, it must be going my way. Right, so, the number is 4, the length is 533, minus, which number up there? Is it the 21.3 or the 21, or 12.8? Who can remember?
21.3.
21.3? You know what? I knew that was a really good guess. And for that, I'm actually going to not give you any marks for guessing. You knew that was a good one.
No, I didn't.
No, you didn't. 4. Here's your big chunk. And it's a race.
What was
490.4.
490.
0.4.
Sorry, 409, 490.
0.4.
No, not 490.4.
490.4.
Oh, 490, it is 490.4. Okay, beg your pardon. So the answer is going to be 490.4, which is 0.4904. So that's one to watch because it could be asked for in 1, 2, 3, or 4 decimal places. So be careful of what you're asked for. If everything else is say in 1 decimal place, then you will only give that in 1 decimal place, which would be 0.55.
5.
Yeah. Okay, but if everything else is 2 decimal places, it'll be 0.49. So just be careful of that one, it's an easy mistake to make. The mass per metre is given up the top there for that particular one at 14. And the answer there is equal to 27.4 for another 4. Okay. Last one is the plate. You'll note that the plate is actually, I'm not sure if that's correct or not. We need to look at the model answer here. I think this might be incorrect. Yeah, I know. Okay, so just so you know, the answers that you'll get won't be anywhere near as extensive as this. I will just give the straight answers like that, okay? So coming up to this one here, the
7.46.
the plate is called up as 250 by 500 by 20. 250 by 500 by 20. Okay, so this is the correct one. The other one had the plate as 500 by 250 by 20. So be careful of this. The answers is what you should be going by. Okay. So what I'm trying to say is with a plate, and this is also a multi-choice question, how do we call a plate up? We always call the plate up as the width by the length by the thickness. Okay? It's not length by width, it's width by length. So that answer is 100% correct. Have a look at the plate there, 2 times 0.5 times 0.25 times 7860, and whoever gave me that 44 was wrong. That was naughty. 46 apparently. That's half a mark off, I think. That's going to be equal to 2 by 0.5 by 0.25. And over here, another mistake easy to make is forgetting the 0 there. And nothing there. So that's 250. I'll get this right. 250 by 500 by 20 PL. Incidentally, you may be asked for the width, which is that width there in the test. To find that width there, we'll call it x. X equals that distance, which is we don't know, so it's not going to be asked in the test. There we are. You're not going to. Oh, yes, you are. 210. That's the old way of calling it up. So if you are asked for it, it's 210 minus the thickness there, which is 12.8 at the top, which equals 210 minus 12.8, and that's divided by 2. So what does that equal? I'm struggling with this thing here. So x equals, can someone do that? 210 minus 12.8.
98.6.
98.6.
98.6.
So that distance there is 98.6. You may be asked to calculate that one way or the other, okay? That's the golden mark. And now what you've all been waiting for with bated breath. Not sure how much of that you can see. Can you see all that up there? Yes, you can. It's not too bad. Not quite. We're not quite finished. There's a couple of notes at the bottom. That there may not be written in the test. Remember I said 32 is the magic number? If there is no lat given on a table like you had for the assignment, assume 32 times the diameter of the bar. Now, if there are two different bars, one's a little diameter and one's a big diameter, which one do you take? Big diameter, yeah, okay. So don't forget that either. So yeah, the test has got a couple of little twists in it as well. Wouldn't be one of Roger's tests without it. Okay, well guess what? It's time for you guys to do some work. I will show you the calculations for that on that board down the other end there. In the meantime, I'll give you 5 or 10 minutes to have a little bit of a crack at that. Look, the only thing you might be able to do is the bars going upwards. What I will do though, is I'll do a little sketch here of what the bars actually look like. Remember, you're pushing them as far towards the outer edge as possible. Let me have a go at trying to show you how that works. I'll also sketch what this is for you.
Yeah. Ready? Not really.
So that's how the bars look like, okay? I'll try and do that sketch for you before you sit the test as well, but it will be rubbed out during the test, okay? There's another thing that I will remind you of before the test, but I won't be answering any questions during the test, is the 0.2 rule. You know, when you have the distance and you divide it by the spacing, and you come up with a number like 25.199, does it go up or down?
Down.
Down, correct. So that'll be 21 spaces, 22 bars, right? If it's comes at 21.21 or 2,
Up.
okay? And I'm warning you, just a little bit of a heads up, there are a number of ones that come to 1.999 or 2.2. And the brain goes, oh, what did Roger say before the test? Yeah, so you need to remember that somehow. A good way to remember it is to chop off 3 fingers, so you've only got 2. There are other ways as well.
I'm not sure what 1601 is pointing to, if it looks like the same as 1602.
The blue ones are 1601 and 1602.
So the same.
The same bars actually, yeah, but so you only need to calculate it once. So if you get asked, you're going to get probably about 4 questions from this. Okay, roughly. So if you are lucky enough to be asked 1601 and 1602, they're actually 100% the same. So you'll be sitting there with a big smile on your face. You only have to do the calculation once. Actually, incidentally, the numbers of these bars here, not the other bars, not these ones which go all over the place, not the black ones, but all the others, they go that way. So all you need to do is calculate the number of one of those, like say 1601, and because they all lap with each other, the number will be the same for all of them except for the black bars. So if you get asked in that reinforcing sheet, you get asked a couple of the number offs, assuming you calculate one of them correctly, it's easy marks. Okay? So keep going. I will go over this step by step for you. Once again, there is answers that I'm going to make available, but they're not as intensive as the board answers will be.
What's the length of the symbol?
Length of what?
Length of that symbol, what would that is?
That is there on at 1550. What's the length? Yeah. I probably do need to do a bit of a sketch of that. I'll do it here for you. It's going to be, what is an abutment? Okay, I'll explain what an abutment is, and I'll show you how the length is actually the width. Okay? So an abutment is something that sits like this, and this will go down to a river or something and come back up on the other side, okay? So here's Roger sitting in his boat fishing at the bottom. What we have here is we'll have probably some piles, and we'll have some raking piles probably going into the ground up to a point here where we'll have sort of something that sits like that. Very, very crude sketch. And on here, oops, we have our beams. So let's take the beams across. We're quite a bit out of scale here, so let's put some scale into perspective. Another beam going over there, and another one going over to another abutment on the other side. So what the abutment does is it ties in the bridge to the land, I guess. All right. Sometimes it has raking piles going into the ground as well, depending on the design. This part here is normally hard fill, as in like a road surface, different layers of sub-base. And this bit here is normally something like a flexible pavement of some sort, like bitumen or something like that. In here, they also put a flexible compound, so that obviously with the concrete expanding and contracting, it doesn't actually sort of mean that you're going to come along and there'll be a big gap there. But you always find when you're driving onto a bridge, even anywhere in New Zealand, there's a bit of a dunk as you go over that bit, and a dunk at the end, right? And sometimes in the middle as well, but normally there and there. which is the bit that takes up the expansion, all right? These things here are generally designed all over the world where they're precast, because particularly if you've got motorways that you're going over the top of, they want to do it at night, and they've only got a certain amount of time, so they don't have time to set the concrete and all the rest. So it's all precast, crane, bang, bang, bang. That's why you'll find that you'll be driving along a motorway one day, the next day there's a big bridge going over that they've been working on all night. So this here is referred to as an abutment, and what it looks like in 3D is, I'll do it here if you want, is sort of something like this. Okay, and this part here is called the width, because it's the width of the road. It's referred to as the width of the abutment. All right. So up the top there, you'll see width of 3.7. Is that right? 3 point something. Down the bottom. Sorry, of that page. Width of 3.7. Yeah. So in your case, the width is 3.7. So that's that distance there, which means the distance it goes into the wall. All right. So we don't refer to it as the length, we refer to it as the width.
So it's the width of the abutment.
The width of the abutment is what you probably think of as the length of the abutment, yeah.
But the length of the bars is the width of the abutment.
The length of the black bars, yes.
Yeah.
Yeah. This is not referred to as the width. All right. That dimension is over there. So this little sketch might help you understand a bit cheaper than me doing that. I'll do that. How bridges work, all right? And I've done a number of these over the years. I was sent out with a survey crew, which I hated in the middle of winter, and we had to set out these abutments, and we also had to set out some of these when the river was down quite low. And I've also been involved in some of the drawings for some of these, and some of these drawings at the bottom are quite intense. There's a lot of reinforcing goes into that. Yeah, so it's something that you could well come across in your engineering life. There's lots of bridges around Auckland, and they're only going to be designing more and more of them. Okay, so let's give you another 5 minutes, and we'll get on with doing the answers to this. Do you now know what the width is?
So that 1550 is what we're looking at in section, or is it the other way around?
1550 is there.
Yeah.
1550 is this one here.
And that 350 is just that.
350 is that shape there, is that shape. Yeah, my very crude shape there is, you're looking at the two different shapes. Yes, I know it's thinner and all the rest, but the test is going to have an abutment. It will look like that. You'll get a sketch with those numbers. You'll get a sketch with these. The bar sizes won't necessarily be D16s. The spaces won't necessarily be 250. The cover may not be 40, it might be 50 or 35 or something. The centres will be different. The abutment will be given to you. This may not be given to you. I'm not sure, I can't remember. You need to be guarded on that. Get ready with your 32 times the bar length wheel out. You now know the width, which is this one here.
Oh shit.
You know what that means? That means how you calculate how many of those bars there are, the colour ones, because it goes that way.
What's that location, the bottom one?
WPA.
The bottom one, we're talking
Schedule the
EWPA.
location. On the schedule, the
The
location.
location. EW.
WPA.
each way, each face. You won't be asked for that. Yeah. So all you're going to be asked for is something similar to what's there. So I'll give you an idea. The easy ones will be F, E, D, C, B, and unfortunately 16 is a hard one to calculate. 1606, so that'll be a hard one. Bar lengths. This one that curves around like that's quite easy, in my opinion. That's 1604, 1603 and 02 are hard, and 1601 and 1601 and 1602 are easy. 1603, 1604 are hard. The 1605 is easy. The length of 1606 should be very easy as well. So that's how I've broken it down. If you get K and L, that's pretty simple as well. And the totals on the right are relative to, I think I've made all the totals hard because you're going to have to calculate 2 or 3 things. All right?
You can't count just the black dots, can we? Have to divide it.
No. You didn't do that with Simon, did you? No. Okay. Yeah, you have to divide it. You have to divide it into 2 boxes.
Bend allowance, if it's not given, what's the equation for that? We can't do that.
It will be given. Okay.
But in case if it's not, has knowledge. Something times the diameter, or middle of the diameter.
No, you're getting a little bit mixed up with the actual diameter itself. Your bar comes around like that, right? The centre line of the bar is 2.5 times diameter. The inside is 2 times diameter, and the outside is 3 times diameter. The curve. That's what those are. To calculate the bend allowance on, I don't think it's a constant number, because you've got an arc of a circle. It could be. Yeah, sorry, off the top of my head, it's a little bit complicated. So I will be giving you that. I won't be making you calculate that. Normally there is a chart with that on it for each bar. Okay, well, we all want to get out of here before 12:30, so I better start doing the calculations. Let's start it with the 1601 and the 1602 bar. They're both the same, so they're easy enough calculated. Okay, so 1601 is going to be equal to the length of the top section minus the cover. The cover is 40, and the length of that is equal to 1,000. So it's 1,000 minus 40, which equals 960. But it's not 960, is it? Or is it? Let's have a look at what I've put in there. So have a look at the bottom thing, table. Yeah, it's 0.960. Remember that? It's in metres. So the answer might be 960, but it is actually equal to 0.960 that goes into the onto the table. Same for 1601 and 1602. How many bars are there? So the bars run that way. So looking at this here, the width of that equals 3.700. So 3700 minus 40 equals 3620 divided by 250 equals.
All up.
You got it?
250 is
Fifteen.
number 3? Yeah.
15.
Point.
14.48.
14.48, which equals 15 spaces,
16 bars.
which equals 16 bars, right? Now the good thing about that is, when we do 1603, 1604, we can say there's 16 bars there, there's 16 bars here, because they all overlap onto each other, and there's 16 bars on 1605 as well, wherever we're going to do that. So that number that we just calculated there is really, really important in this particular reinforcing example. So get it right, and there's a chance you might get 2 or 3 questions right. Get it wrong, and you're possibly going to get all 3 wrong. I get a lot of students that get a mark back after this, and they go like, I've done all the calculations right. I don't know, where have I gone wrong? Well, I can't tell you that, or else I'll be. The whole reason for an online test is that you don't spend hours and hours and hours on emails giving feedback. They've been tested, they've been checked. There's no problem with that. And normally when you go back to looking, the student's made one small error and unfortunately has not checked it, and it's gone onto each answer. So really important, that one, to check it the second time to make sure you've done it right, because it's quite possible you'll get asked for example, I've rolled that up a little bit too far, you might get asked for F, E and D, and they're all the same answer. Okay, so that fills in the number off there, right down to 1605. And also we now know the length of 1601 and 1602. So let's look at this bar here, which is 1605. So this bar here, let's look at the length of that bar. The length is going to be equal to those 3 lengths there. And they're very easily calculated. The width of that is 350 minus 40 at each end, which equals 270. 270 over here. Along the bottom it's 1550 minus 40 minus 40, which equals 1470. Therefore it's 270 plus 270 plus 1470 equals 2010 minus the bend allowance minus 80. So minus 80, which equals 30. So there's your length. Good. Yeah, yeah, correct. 1.93.
It's always in meters or will be?
Always in meters. The answer is going onto that chart, and that's where you're being asked for it. These calculations and answers that I've done are in millimeters to make it easy for students to answer, to figure it out. But up there, when you ask for it, it goes on that chart. The chart is in meters, and because the mass or total weight is in kilograms. Okay, so 1604 and 1603 are a bit special, and 1606 we need to calculate the number of bars. So 1606, we divide it into the top and the bottom. Now the bottom and the top are done very differently. The top is done by going 1000 minus the cover, divided by 250. The bottom is done by calculating the curve. So I'll zoom in on that. For those of you that bothered to, I don't know how many actually went through the class exercises and the model answers, because there was a lot of hey bro going on, but anyway, some might have. I have confidence that some did. On the corners, the distance to that bar is going to be the cover, which is CVR, the bar diameter, and 2 times the diameter. And that is taken at both ends. So it's going to be, what's the length of that? 1550 minus 2 lots of cover, which is 80, minus 2 lots of the bar diameter, which is 32, minus 2 lots of 4 times the bar diameter, 64. So that's going to be equal to, all of that divided by 250. So all of that divided by 250. That's cover of 40, and that's cover of 40. So that's how we calculate the amount of bars, but we have to also be careful because we've got bars on both sides. So whatever answer we get, we multiply it by 2. So can someone do that up the top? So 1000 is 920 divided by 250. What's that come to?
3.68.
2.68? 3.68. So that makes 4 spaces, 5 bars. Times 2 is 10. Right? Times 2 is 10. 1550 minus 80 minus 32 minus 34 divided by 250.
5.496.
Big pardon?
5.496.
Yep. 496, which equals 6 spaces, which equals 7 bars, which equals 14. So the total bars equals 24. So that's a tricky one, and that's going to be the formula that you'll use to calculate 1606. I can tell you that your reinforcing will look exactly like that, but it'll be different bar sizes and different numbers in the left-hand corner there. All right? So this will change, and the cover might be different as well. So there'll be different numbers, but you need to understand the principle. I suggest at some stage between now and next week that you all maybe get together in a little group and see if you see what you do and don't understand of that, okay? Because once the test starts, you've not got your group together, so it's important you all understand how to do it. There's no lecture next week, so you can have a sleep in. I would suggest that those on the Wednesday class, well, everybody really, should be using that time to study for your test. All right? Up to you, do whatever you like with your time, but I'm giving you that time to study for your test. And you need to be in your timetable test next week, please. Unless you have a SAC approved, you must sit it in your timetable test. Otherwise, I will have all of Thursday's class cramming into, all of Wednesday's class cramming into Thursdays to get an extra day to study for it. It's not fair. If you want to do that without an SAC, you can. You will lose 20% of your mark if you decide to do that. Your choice. That's quite a bit, that's 4 marks. So what I do is I have a class roll and I check it against, I can see who sat it on Wednesday and who sat it on Thursday. Okay? Okay. Well, we've calculated this. Does anyone know the length of this bar is pretty easy. The length of this bar, we're talking about the black bar there. This one here, 1606. It's just the width
Minus the hours.
equals 3700 minus 80, which equals 3620 or 3.620, okay? Which is what you should be putting into the.
What number is that?
That is number 1606. Maybe I can put red around that to make it a little bit clearer. 1603, 1604, 1605, 1601 and 2, and 1606. All right? I love it when I used to teach in a classroom just before one of those classes that comes in that uses the other side of the brain, like English or something like that, or literature, or I don't know, ballroom dancing, who knows. And they used to come into my class, and this board used to have everything on it like that, and I'd just walk away and the lecturer used to sit there going, and all of the students used to walk out the door going, oh, that was easy. And you'd see the others come in, and yeah. But unfortunately, we don't have anyone coming in after us, so I'll have to clean the board off. Make sure you take a photo of this before you go. You might have to cut that bit out of the video, by the way. Get me in trouble with some of the other departments very quickly. And my wonderful friends.
Did you say that length